Yeah. There we go. I like that. Hello, hello. How are we doing today? Just clearing off here, we're going to get a little demonstration started on what an electromagnetic rotor is all about. It's virtually the same thing as a standard motor, but it's more, I guess, well, all the power and the electromagnets and all the coiling goes on the rotor. It can spin. So it's only like, and I believe that with that being the case, that this interacts with the environment differently than the other type of motor would. I got two designs going right now. I got the radial flux, which is this one. It's pretty smooth. I like that. I mean, the base is a little wobbly. So I've been trying to print a new one for a few months, and it just none of them have come out well. I don't get it. What the problem is? I've changed the temperature. I've done everything that you can do with the printer, and it's like just the center hole, the part in the middle, like never is straight. Only when I do the rotor, and I use the printer that I used to make the rotor, it's straight every time. But it's not like I've never made a straight one with the other printer. It just hasn't happened. It might be a software issue. I don't know. I don't know. It'd be nice if I could get a good larger print like that. I mean, this one's all right. It works. That's all I can say about it, though, is that it works. Now, the one that I'm making right now, might be able to hear it going on in the background, is it's an axial flux, so it's going to stack up. It's got the same coil assemblies. Alright, so it's got a drive coil and a pickup coil, or a generator coil. So there's 2 coils on each one of these pegs. So there's 8 coils on this electromagnetic rotor. And, let me turn this off real quick. I don't know if you guys could hear me or not with the headphones on. I could hear myself for sure. Alright, so, and I'll take you over to see the other design. I just put out a short about it. It's a 180 design. 180 seemed to work the best. And fit the best. And in there, that's the permanent magnet rotor that'll go on top. And it's going to be a counter-rotating device. It's going to be awesome. Oh, alright. Where were we? Yeah, I'm printing off, it's a 1/2 inch of a base for the electromagnets and everything to go on and spin. I'll show you what it's on right now. I'm not going to use that because I don't believe that it's centered properly, and I believe that it's off balance. So I printed one that was centered properly and had a little marker to show where it was at. So that's pretty much. So there's 2 drives on this one. Let me turn them on. There's 1. There's 2. Let me turn this off for ambiance and aesthetic purposes. I don't like that. See if that'll happen. Alright. So it syncs up pretty fast with both drives going. Wow. It's got, you can feel how much more torque it has. I mean, like, the torque it's not like sledgehammer torque. It never will be, but that's not the point that I'm trying to make. The point that I'm trying to make is you can feel how much more there is with both drives on than with just one. You can feel the difference. I mean, there's a feelable difference there. Huh. It means it's twice as hard to stop with my finger, no matter what speed it's going. I mean, there's definitely going to be a point where I'm not going to be able to stop it with my finger anymore. I'm not trying to get there really fast, you know what I mean? I'm trying to avoid that without actually manipulating the system. You know what I'm saying? I'm relinquishing my control over the system to see what basically I want to say nature would provide. Say, without speed control, how fast do you think this thing could get? mean, I've already proven that it's going to counter rotate if you untether the stator. You make it so the stator can spin, it's going to counter rotate. I've proven that, like, with more than one way of switching, like 100,000 different ways. It's natural for them to counter rotate. What I'm saying is that the outer the stator, if it can move, it's going to move the opposite direction that the inner part or the and if they both can spin at the, an equivalent speed, which these can. I think the inner part can spin a little faster, even though because it's like got some hybrid bearings in there that are pretty awesome. Now that little bounce back that you see there is the battery. There's 2 batteries in here. And right now, all the pickup coils are doing are just dumping into these LEDs. But you can see the power surge when I turn it on. Looks like this battery's getting a little low. No effort at all. It's like it wants to do that. So that's a law. I bumped into a law. Now I believe I'm about to bump into another one where they sync up. Okay, and once you get that sync up, then you can start doing other math, like Arduino and stuff like that. You can start manipulating it more once you get that sync up math. Once you get it to sync up, and the RPMs are the same on both the stator and the rotor, they will increase and decrease at the same rate. So there you go. I mean, and that's if conditions remain good. The bearings don't get gunked up, there's no problems. And I mean real basic problems, not nanonite problems. Talking about problems you can see. Like, oh my God, my transistor's melting, this isn't going to work, kind of thing, This is so rough that I don't think that any of that other stuff really applies here. It just doesn't. I mean, we could think about it if we want. I mean, all the basic principles apply. Like right now, how the circuit is connected. You have a trigger strand which is connected to the base of the transistor, which is an NPN transistor. And then you've got, you got your coil, positive end of your coil, or the start of your coil, depending on whether you wrapped it or not. If not, the positive end should be marked, or if you can use a multimeter. Yeah, so you hook it up. And all those principles that apply when the stator doesn't move are pretty much the same. The only problem is that they're not synced up. If the stator and the rotor aren't synced up, then that math is really hard to grasp for like sending it code or having it be speed controlled. But I believe I may have found at least one option, and that's 1-to-1. One electromagnet to one is good, but it also has to be parallel to another 1-to-1. So is that 2-to-2? It might be 2-to-2 on each rotation. So the middle's going to speed up really fast, and then when they sync up, they're going to increase at the same rate. I'm never going to let it get that fast, though. Now let's try the middle first and see if the outside syncs up. Looks like it needed a little bit more time, but it was getting there. So what I'm going to do is I'm going to turn off one of these. What I do, just to give myself peace of mind, is that I run the tests on a separate wheel of just the coils to make sure that, in my mind, something's definitely happening here. It's not. See, the thing is, when I believe people when they say that I'm generating or I'm using a generator coil, it doesn't mean at all that they're putting in 12 volts and getting 13 out. That is not what it is. Not what generation means. For some people, it is what it means, and I believe that's where a conflict might be occurring. It's like a vocabulary disparity. You know, like some people may be using the vocabulary incorrectly to describe something that they know they saw. They just don't know how to say it. And it's like people get offended that they don't know what they're talking. And it's like, dude, just tell them what it is so we can know now. You know, just say, yeah. And then it becomes your responsibility. Once you can tell that somebody doesn't know what's going on and you don't say anything, is it then your responsibility? I don't know. Because you know now. It's not like you're ignorant to the situation anymore. Like, oh my goodness. I don't even know what I'm talking about right now. I have no idea. I know it was pretty cool while it lasted though. So how's everybody doing today? Yeah. See, but all the mechanism, I don't even know, like, the mechanism that would be used to slow it down. I mean, I could see it there being like a timed situation where you pre-programmed it to slow down. I can see that happening. I can see where you've had maybe a remote situation happening where you're using infrared or something like that to trigger a situation on the rotor with a button or something. I can see that happening. Both of those methods would be cool, like really cool. If I could figure out just like to time an Arduino or something like that to trigger a reverse capacitor or something like that. But what I really want to do is, in this confined space, create a way to do that without actually using anything digital. And I don't know if I think I've successfully done that. So I don't know if a transistor is digital. I don't think it is. I think it's more analog. But do the exact same thing analog, basically. Yeah, beat a washing machine apart? Yeah. This is it's an electromagnetic rotor with let's call it a variable stator. See, the stator can move and switch position. It's pretty much on on 60-degree angle though, or 180. I don't know exactly. There's a hole every 60 degrees for a magnet. So I can put 4 more on here. But right now they're at 180 degrees. And it works basically the same way that conceptually I want to say that like a Bedini motor works or a Newman motor works. And then of course there's the toroidal effect that goes on when you have the stator untethered. So yeah, I don't know. I do want to have it all on a remote or a switch. I just, and somebody offered up a PCB board. I'd be like, that is awesome, man. And I'd draw it up. I'd be like, is there any way you can put the power switch mechanism on there and like put all the component slots on the board so it makes sense and it's all balanced and everything. I mean, I'm making the most sense I can out of it out of the components that I have. And it's not an excuse. This is not an excuse. Okay? So we're running with just one drive on. You know what? I'm thinking maybe we take all the energy from the pickup system and we put it into a cap bank of some kind. Where is that thing? Anyway, I got like a 5.5 volt, 10 farads super cap. Got 2 of those. Put those in series. that was just one drive. That's awesome, man. That's cool. Alright, the next one that I'm making is going to be run on 9-volt batteries. So this right here, this is the power supply for the next one. It's going to have 2 of these. Okay, and for the pickup coils, it's going to be each pickup coil is going to be connected to its own one of these. And that takes AC and DC and puts it through some bridge rectifiers and then puts it through some caps and it comes out DC. Alright, so yeah. As long as that there's no like, because there's typically, and this is why I suggest that this is never going to have a commutator on it. Because the shaft is fixed. The shaft does not spin, it doesn't move. Okay, everything rotates around the shaft. Now, if the shaft was what was spinning to begin with, then you could put a commutator on it and everything would be fine. But when you do it like that, you got to attach it to, you know, either this part or the other part. And since it's the other part, this part that you want to get the electricity readings off of, or any kind of reading whatsoever off of, you want to attach the commutator to the one with the electromagnets on it, which is the one in the middle. And I mean, without wireless capabilities, you see how difficult all that's going to get, right? I mean, the typical slip ring goes about 300 RPMs, 400 RPMs for 10 millimeters. Okay, we're not just going to rebuild the whole thing to, you know, that's awesome. That's awesome. And I know. It's not like that's what the suggestion is, to rebuild the whole thing. But I am rebuilding it. The majority of the electricity is coming, that's going through the lights right now, is actually coming from a battery. Here, let me show you why. And then I'll show you something else that I found out. That's off now. Okay, we're spinning. See, there's no light. I mean, the batteries are off and there's no light. When I spin both of them really hard in opposite directions, nothing happens. Now I put the other one in. Now there's 3 permanent on the outside. We're like getting more energy than went with the battery now. It's amazing. And that's because all that magnetic energy is now, I believe, the way that it's all configured now, less of it's getting out. So you got a magnet pushing at every 120 instead of just the 180, and there's all this leakage coming out the sides, and now there's less leakage. That's awesome. That is so cool. There's no power going on in here right now. Oh wow, man. I love it when I get the lights to light up without the power actually being on. That's like pretty much all it can do. The AC that comes off of those coils is light LEDs up. But that's what these are for, right here, is to change all that, AC electricity that can't be used into DC electricity that can be used by the system. Whatever it looks like on a different overlay is fine. That's great. I'm talking about what I'm going to use in this system. I'd love to use an anti-entropy circuit so that it can, it might just be a small manipulation of the circuit that I already have in here. But basically what it does is it takes energy that is dissipated into the atmosphere and takes it back out of the atmosphere. It's like taking the energy that comes out of a black hole and reconstructing it into what it was before it went into the black hole, which we all know is just mind-boggling. I like that sound. Wow, dude. See, what the problem is that I take it to the threshold from the start. I don't like work my way up to where it gets to the point where it's going to get away from me. I start there, and I work my way back. So like I know, and I lose sight of that sometimes. I lose sight of the fact that I'll just move right up to the front line, and then all of a sudden I'm there by myself. It's like, whoa. let's take a look and see how the base is going for this new one. It's coming right along. That's ABS printer filament. K12, K1C, K1C. I was thinking about getting a bigger one. And then this is my work table where all my stuff is currently that I'm using or thinking about using. There's that. It's my winding station. My winder fell on the ground last night. All right, I got a question, and I'm really debating on how I'm going to do this. Got these bobbins right here, just black one. This big one right here. But I've got 32 gauge. I've got 30 gauge. I got 28 gauge and I got 26 gauge. And I want to put all that on one spool. But what I want to do, what I'm debating is whether I should just wrap all the 32 and then at the end of that start wrapping the 30, and then at the end of that 28, and at the end of that the 26, or do I start wrapping them all at the same time and then just end them as they end? And well, they're all going should fit on here. I'm trying to make like a generator coil. There we go. Out of all the thin gauge wires. All right, then we're going to check this out. All right, there it is. The new design. And they're each going to have their own 9-volt battery with their on-off switch. Yeah, I think this one's going to be good. I hope it's balanced. See, that's what I'm wondering, if it will be balanced or not. I'm pretty sure it'll spin up to a certain point without any difficulty. It's pretty equal on all sides. I'm not sure if that's what is the only thing that's designed to make it balanced. It's got 2 ceramic bearings in it. So that's going to be neat. So what I'm getting at a lot of the time about this is that essentially it's a proximity generator. So you got your drive coil, and you got your electricity from the batteries going through the drive coil, and then through proximity, although they're not connected to each other or literally touching each other, there's, you know, insulation there, there's a little bit of space there, they're not connected. But through proximity, you get the, I like to call it the imprint. And when that imprint is similar size, this is what's happening in my mind physically, the electricity, because there's literally something that when the magnet passes and the coil is shorted, basically, or grounded, there's two things that could be going on, shorting and grounding. But when it gets grounded, when the trigger is triggered, there's a force there, an electromotive force. And that same force can be picked up by the pickup coil being through a proximity and being in the pole. Okay, so not only is it close, it's like right in, you know, point blank range. So it's getting the most it can. See, I tried hooking it up to a really big coil, and it sucked. It did not work the way I thought it would, and I believe it's because it's way oversaturated. It's better to have the coils, if you're going to do this at all, be similar sizes. They don't have to be the same gauge. It's just like 5 ounces is 5 ounces. And each one of these coils weighs 5 ounces. Although they're not the same composition, they're not the same gauge. Okay, they're not. One of them's bifilar at 20 gauge and 28 gauge. And then the other one's a 30 gauge coil. But they both weigh the same. They're both the same size. They're on the same size bobbin. So when it hits, when this gets turned on, okay, when the circuit closes and the coil gets turned on, that imprint is going to be left in the other coil. And the less air and the more space that's filled up in that coil, meaning a thinner gauge, the more the imprint's going to get picked up. And it's overlay. It's just like putting the green paper. The green paper right here over the magnet. When this coil is on, you would get a similar effect, and that area that's lit up around the magnet would be set, you know, being caught or picked up by the pickup coil. And does it work? Yes, hell yes it works. That green paper lights up with electromagnets just like it lights up with permanent magnets. It's awesome. Another thing is that the way that this electromagnetic rotor, the electromagnetic rotor interacts with the environment differently than the permanent magnet rotor would. Because every time this one spins, it's going to pulse too. Every time the stator spins with the permanent magnets, it does not pulse. So the interaction with the environment right off the bat is different. Is it substantially consequential? I don't know. I just know that it's different. You know, people that believe that this is a time machine, that's how time would be disrupted. It would be gripped by the electromagnet when it's pulsing and then pulled as it's spinning, unveiling whatever's behind the veil. I don't know about all that. I know that this works like a brushless motor. That's basically what it is. It's a brushless motor. I do know that it interacts with the environment differently, though. That's a given. See, with the other one, the permanent magnet moves and the coil stays still. You can do a lot more tests that way. You can hook it up to a speed knob that way if you want. You know, you can do anything you want basically with it that way. You have a lot more control over what's going on if you make it so the electromagnetic energy is still. You change all that, then you gotta like change everything about what you're doing. All the power. See, there's 2 batteries in here too. So you need your power, your circuitry, and your coils all on the same platform basically, which would be your rotor. Now, there's a lot to this that you're not seeing. Well, not a lot, but a little bit more. Okay, so I don't know if you can see that right. You got that. You got that. So it's magleved. And then there's 2 batteries in a box lined up with the coils that are being used. See, with it being magleved, it moves a lot smoother, but if I took the maglev out, it would drop down a little bit more. And I might even be able to put the cap on. So this thing is supposed to be an neutron, right? But it's only half a neutron. And even with this on it, you kind of just get an idea of what it's supposed to be. And see how, with it being the shape it's supposed to be, if it continues on that trajectory, it's going to cut off half of the whatever's on there. So, well, I don't know. I mean, we could get it. See, and then you take the maglev off, and then it might work. You might have that clearance. But as of right now, the Utron cover top won't work. And then of course, we still got to find a way to turn it off basically without having to touch it. It's so neat. You get mesmerized by the lights. Yeah, that. All right, let me explain what the issue is, if there even is an issue. The hole that's in here, where the cavity, where the rotor is resting, is as deep as it can be without breaching the outer wall. So yes, it can go down a little bit farther, and I'm going to do that. But it can't be maglev. That's what I was getting at. So I got to remove, there's a magnet in here. Now this is going to be a crapshoot. Looks good from here. This is probably as low as it can go too. If it doesn't have to be moved up at all. Really close. Now, if I'm lucky, that's all the adjustments I'll need to make. Yeah, that's almost touching, like, literally. close. It's really close. And I mean, worst comes to worst, I can just make it a diamond instead of a neutron. And just by adding this, you got that flat part in the middle, and put that on top. Or the cone, I make an actual cone. Yeah, this is not what I would be putting out there if I was going to sell it, sure. I do this to try to get ideas to continue to build stuff, you know, I'm not trying to sell anybody anything, really. So it's like, yeah, if it doesn't look like it's a final product because it's not. I like it though, I like trying to get there. I could try harder, you know. I could do better, honestly. Even with what I have here, I could do better. Saw it through the lens, I was like, yeah. Might even tape it on there, try and keep it straight. But there'd be no way to stop it then, you know, if I turned it on with this actually on there. That's why the remote control stuff has to happen first before I can like put the cover on it. I have no idea how to do that stuff. Just that it needs to be done. And this is where, you know, people, they get half of the patent, half the stuff they need to make it something sellable. And then somebody with money comes along, and this is how it should go. It's like, yeah, sure, I'll buy this from you, and then I'll turn it into something worth something. And that should be fine with everybody. If it's an agreement, that should be fine with everybody. But I believe what happened to people like Tesla was not okay. I don't think that was okay at all. I understand that, you know, jacking him, taking his stuff, the government felt that was a necessary move, and it probably was at the time. Maybe even now, you know. I don't even know. I don't know. What I do know is that if I was, I don't know, on my deathbed and there was a bunch of guys robbing me, I wouldn't feel very good. But then again, because they were federal agents, it was probably somewhere along the line that it was, you know, quote unquote okay. Oh, and I don't know anything about it. That's what I heard. About, you know, on the documentaries and stuff like that. That's all I really know. I don't read. You know, a schematic is as close as I get to reading. You know, the proper measurements of something, that's how, as close as I get to reading stuff. I don't know why. Like, I put a block on myself a long time ago. Like, I got really, you know, turned off by how easily manipulated the word itself is. Alright, so this is without the maglev. Let's see what we got. Sometimes you gotta give it a nudge if you don't spin it hard enough. You know what I think that was? I think that was that little coupler that I have in there. This probably isn't going to work for long term. And you know, it's not enough clearance anyway to do it the way I want to do it. Alright, so put that maglev back in there. And I mean, it didn't give me that much more clearance even with the maglev. So I'm going to leave it in. And then, but the problem, I'll explain why it's like this. Why it just seems to be too big, right? And it probably is too big. I guess whenever I'm creating something, I gotta start somewhere, right? Usually where I start is somewhere that I didn't create. So in this case, it was the bobbin. The bobbin is a certain size. Let's say it's about, literally about that big, about 2 inches. So every part of that rotor is built around this. This is the only part that doesn't change. I bought these at the store. The bobbins I bought online. And that's just because I never had any luck with printed bobbins. I've printed bobbins. I've printed tons of bobbins. A lot of them have broke, melted. And I have way better luck with the store-bought stuff, so I do that. Yeah, and the magnet. So the permanent magnet on the stator side and the coil bobbin on the other side. And then I found like a golden ratio pretty much. 200 turns of 20 gauge and 200 turns of 28 gauge in a bifilar coil is the same amount of mass as 2,222 turns of 30 gauge in the same bobbin. So virtually you have the same coil, same size, same mass, except one can handle, pushes a ton of current, and the other one, is way more sensitive to the electromotive force. And you can't say that there isn't actually something physically happening there. Because on one side of the drive coil you've got permanent magnet. So on the one side of the electromag you got the permanent mag, and when the circuit closes, the electromag pushes on the permanent mag physically. There's a physical something that happens here. You can't see it, but it's definitely there. I mean, if you can see it when it's moving. You can see it on an oscilloscope, but you can't see it. I wish there was like some powder I could sprinkle on this, and there probably is, but it's not Not what I'm talking about. That would go directly to the magnet or the other magnet. It wouldn't be in the air like I'm talking about. Anyway, and on the other side, you got your pickup coil, which is picking up the same energy that's pushing on this magnet, just on the other side of the coil. Exactly the same energy. So I'm going to call it the EMF. I think that's what it is. It's the EMF, and the pickup coil picks up on that. And if it's BEMF, which I don't know, I don't think it is. I think this is a hot circuit. Currently, I would like to change that though. I want to put an anti-entropy circuit for this. I want to put remote controlled speed control. So yes, it would be on a knob, but it would be wireless as hell. You wouldn't have to touch it or turn on any switches on the thing. Well, you could turn on a switch to make it extra safe. You turn on the switch and then you turn on the power, kind of thing. Yeah. No, man. Well, I don't know exactly what people think he was about. I think he got the short end of the stick at the end, though. That's what I think. But it's not like, it's weird though. Kind of reclusive. It's just that's not the way I would like to go. Unless it's totally misinterpreted and was all his idea to begin with, like the whole taking of his like his possessions and stuff. All right, so what am I thinking? Oh yeah, yeah. We're talking about why this this particular build will never complete, because the top won't fit, because and then the problem is the bobbin. And that's what I was getting at. The problem is the bobbin, and the way the bobbin is. I mean, there are things that you can change in here in the STL files, but it's not going to make it, it's not going to change the problem situation. It is just the angle. Mm-hmm. Now what I could do is, how the bottom part of this is round and then it moves into the box? See, so this round part, just cut that all off completely. But that's definitely an idea. I'll think about that one for sure. That's interesting. It's stuck. I think it's because the battery is dying. There it goes. But yeah, it's definitely because the battery's low. I'm using bifilar coils with a trigger strand on M.P.H. So it's expensive as hell power wise to run it. Yeah, it is pretty cool. Um, I have another rotor already made up. It has the pegs on it, so it'll take the coils, and then it has a hole in the middle of the peg, so it'll take a Hall effect sensor too. So that should be pretty neat. See, and what ends up happening is I always end up trying to do too much, and I always get confined by my space. And my space always cuts me off because this is supposed to be a four drive, 4 batteries, but this is 2 right here. Just imagine 4. You would for a second. I mean, that would be stacked up to here with clips and everything. Just there's no point not to do it parallel. I mean, if you're gonna hook up the batteries in series, that might be one thing, but then that would just be another one of these things on there with another battery in it. So, and yeah, I got smacked down for like the first time since I started doing this like 3 years ago, 4 years ago. And it really humbled me up, man. It's like, okay, so we can't basically do everything we want because it's not going to fit. um, I'm sure that with, more knowledge, I'll be able to do more stuff. It's a very simple circuit on here. Let me see if I got my notebook. Yeah, here it is. That's all it is. Just two of those. I believe I got it from I know where I got it from, but I believe he got it from a guy who was inspired by a Bedini bifilar coil. I believe, maybe it was a Tesla idea, I'm not sure. All I know is that I got it from Hall Effect X. Him used to do things, and it was really straightforward, and the questions and the answers were right on par with one another, and we actually got some stuff accomplished. But I like how I can get the lights to light up. Without actually turning it on. I love that. But basically, I'm trying to remember back to the actual day. I know I was trying to get I think a tip 142 to work with a trigger strand. And I had an external trigger, like just a coil like this, just chilling off to the side like that, and it was working. But that on that premise of having multi-gauge coils, I went kind of I did so many different things, man. I mean, I was gonna do. I want to make this one generator coil right now that has 32 gauge, 30 gauge, 28 gauge, and 26 gauge in it. I just don't know exactly what I want to put, how I want to do that. whether I want to start all of them at the same time from the beginning, or whether I want it to be in intervals, like in series, wrapped in series. I normally wrap it all in parallel. I just get all the spools going at the same time, and then they're all going to run out at different times. But that's okay. As long as they all start at the same place, I think it'll be all right. Just give you an idea of what I'm talking about size-wise. Like that. Have that be all 4 gauges somehow. They don't all have to be the same length, really. Not in my head. For many reasons. One, I'm not going to use it for drive purposes at all, ever. So none of that calculation has any bearing on this coil at all. And really, the more wire that you put in, the better off a generator coil is going to be. The more turns. So always more winding for a generator coil. Now there's solid state generators out there that'll do the same gauge or thicker gauge even. You know, there's been many transformers out there that'll just really jack up your voltage or bring it down. You know, step up, step down, all that good stuff. But this would basically be, I got some spools that are like 3/4 of the way gone, and I'm going to add them all together up in this one. And it's all going to be through the magnetic induction. You know, that's what it's going to be designed to do, so that when the magnet passes it, it's going to generate electricity. I don't care about the amps. I know it's generating a few amps, not like in typical numerals, but like maybe 26 milliamps is a number that comes to mind with the 32 gauge. But with the 26 gauge in there as well, you know, you're going to have the ability to have more amps. I'm thinking right around 46, 50 milliamps. It's going to be the generation of this coil through magnetism only. And it probably could end up being more, and that's unloaded. All we're doing is sending a magnet through this coil, and we're seeing what happens on the other side through a meter. But typically, this big coil right here would be attached to one of these, and the AC from the coil would go in one side and out DC the other side. Now, speaking of Bedini, this coil doesn't have anything to do with him, but the way that he transfers energy through the collector connection would have a tremendous effect with this coil. This is a 16 gauge trifilar coil. It has 2 strands of 16 gauge at 100 turns apiece, and then it has a 126 gauge strand at 100 turns. This was hard as hell to roll. This is not uniform by any means. It is tight as I can make it. it stripped both of my rolling machines, man. It broke it. Like, I fixed them, but I wasn't gonna roll this type of coil again with that. Did the rest of it by hand, so it's kind of loose actually, but it's okay. Anyway, what I was getting at is the Bedini style of clipping the diode to the collector and sending it through. The energy that's going to come through this coil at 16 gauge and the energy that's going to come through the other coil at 20 gauge, you're going to get way more amperage capability with this coil. Way more energy can flow through this one than the other one. And then whatever resistance you would put on it would even improve that, more, I would assume. But this would be the drive coil, and I swear to God, this thing weighs like 2.5 pounds. We'll weigh it in a second. And then the other coil I was just mentioning would be the pickup coil. They'd be both roughly the same size. We're going to find out what that mass is going to be here pretty soon. Alright, we're going to move into a different area real quick, so don't mind the bounciness. And then I got to put Alright, so here's our Weight Watchers scale. And there's our other build, by the way. It's going to be a 180 degree build, since the other one is typically just a 180 degree as well, because I don't use the other two. Alright, let's see here. With bobbin, 1 pound, 10.5 ounces. So an ounce is 16. Or a pound is 16 ounces. Is that right? I don't know. I think so. So it's almost 2 pounds. Like 1 2/3 pounds. So with that in mind, I don't want to go much above that than 1 2 3 in the other coil. It's just something to think about, for me to think about. We're getting there with the base that we're printing off behind here. It's coming along. You see what percentage it's on. 48%. Alright, so currently the circuit that I am using on all my counter rotators is this one. Call it the 1 2 3. Got 1 connection to the base, 2 connections to the collector, and 3 connections to the emitter. eventually. I'm just going to use a signal generator. Let me go get my circuit real quick. We're going to take a look at different solid state generator things. Looking for some iron too. Do some display here, but I can't find it. I'll look for it though. Hmm. So I'm gonna see which end is what on this coil real quick, 'cause I don't remember. Got it. Oh, man. So that's zero point 0.4 ohms. This coil has got very little resistance in it. shift you. Oh yeah, we're not going to be using that. Sorry, that's what I'm working on right now. If you were confused. Alright. Let me hook up the meter here. Let's see if that even worked. Turn on the meter. Turn on the light. Turn on the signal generator. Start at 750. Turn the power on. Holy smoke. Alright, so I missed a step here. What that step was hooking this up so we can get a DC reading. So let me do that real quick. Now I'm going to take you off of here and try that again. What up? Hello. Alright, so we got what we're doing here is we're sending the voltage to the bottom coil. Top coil's picking up the slack here. Well, we're going to see how much we get off the second coil. We're putting 9 volts in, 9 volt battery right here. We're gonna turn this down to about 800, 750. And we'll turn on the power. And okay, there it is. So at 750 hertz, we're generating very slowly, but we're filling up that cap bank over there. And then I guess we can screw around with it a little bit. I added a kilohertz, and this is what's going on with that. 2 kilohertz. Took them away. We're down to 750 again. $650. See, I'm guessing this way. I'm generating electricity this way. Once it reaches a certain point, there's a lot of pushback, and it's like you know, everything equals out, starts equaling out. But here, this is 550 hertz, and we're generating quite rapidly now. Again, it's a 9 volt battery going into the bottom coil there, and then the top coil is a pickup coil of 32 gauge. Not sure exactly how big it is. It's high inductance. It's a 4-inch coil. Still going up, but you know it's going into a cap bank, so that's what's really going on here. But 550. Let's drop it a little more, I guess, because it looks like the more we drop it, the higher the voltage goes. But that's not always what's going to make it run the best. Is the most voltage. Sometimes a higher frequency is better. $250 hertz. That's so cool. I wonder what this really means. I mean, since it's probably only going to get up to like 37 and then it's going to stop. At least that's what I think. And that is voltage stored in a capacitance bank. You know, there's no load on this. But that is literally nothing is going on except for one coil landing on top of the other one. Um, the duty cycle, the frequency, amplification is all artificially simulated by this signal generator. I'm using the 123 circuit right here. And drop it another 100 hertz. Oh, it starts going down now. So maybe 300. That looks right. 300 hertz. Now, let's change the wave up to a square wave. Right. All right, let's take a look at the sine wave and see if, no, I remember now. We're not going to get anything because it's DC. Anything that is noteworthy via visuals, but we're going to check it out anyway. So we're really low on the spectrum there. All right, let me try something. I'm going to hook it up to the coil directly. See what kind of wave we get then. Wow, that's weird. There it goes. Wow. Hmm. So what to do, I don't know. I'll figure it out though. 25 volts. Not that great. I mean, it is coming from a 9-volt battery, so I mean, it's not that bad either. Look at how much energy is welling up in that cap bank. It's amazing. Alright, we're going to hook up to the pickup coil now. And we're going to see what kind of wave we get from that. Nice. That is beautiful. Hundred and 24-volt spike, or peak to peak, I should say. Heck yeah, look at that. And this wave is coming off of this big white coil right here. And then the coil underneath it is doing all the power. Right here, let's remove the coil from. Let's take them apart real quick. Look at that. Wow. So much more power when they're together. All right, wow. The cat bank is looking rather full currently. So, but that I found that to be rather cool. But that wave I just saw was like pristine. I don't usually see them that clean. They're usually a little slanted or there's something. They're uniform. They're just something's not right with it. But that one looked nice and clean. That was awesome. All right. Well, maybe I'll get back to you guys later on tonight. Peace out. Have a wonderful day. Bye now.